We're going to start the topic of the OSI model and the TCP/IP protocol. So the objectives are that we're going to discuss the idea of layering in data communication and networking and the interrelationship between the layers, to discuss the OSI model and its layered architecture, to show the interface between the layers, to introduce you to the TCP/IP protocol and the functionality of this, and then the addressing mechanism. Right. So what is the protocol layers? So a protocol is required when two entities need to communicate. When communication is not simple, we may divide the complex task of communication into several layers. In this case, we may need several protocols, one for each layer. So you have to understand first the protocol, then the layering as well. Let us see and use a scenario in communication in which the role of protocol layering may be better understood. We use two examples. In the first example, communication is so simple that it can occur in only one layer. So assume Maria and Anne. These are the two neighbors with a lot of communication or the common ideas. However, Maria speaks only Spanish and Anne speaks only English. Since both have learned the sign language in their childhood, they enjoy meeting in a cafe a couple of days per week and exchange their ideas using signs. So they know the language of signs, right? Occasionally, they also use bilingual dictionary. Communication is face-to-face and happens in one layer, as you can see from the figure below. So you can see Maria and you can also see the Anne. Since Maria can use signs and Anne can understand those signs, and in the same way, Anne can use signs and Maria understands what are the meanings of those signs. So we don't need any additional layer in that case. Now, let us assume that Anne has to move to another town because of her job. She has got job in some other town. Before she moves, the two meet for the last time in the same cafe. So they are meeting for the last time in the same cafe where they used to see each other and use those signs. Although both are sad, Maria surprises Anne when she opens a packet that contains two small machines. The first machine can scan and transform a letter in English to a secret code or vice versa. The other machine can scan and translate a letter in Spanish to the same secret code or vice versa. Anne takes the first machine, Maria keeps the second one. So the two friends can still communicate using the secret code. Now you can see, you have Maria, and then she has a translator, and then there is sort of a post office because she has moved to some other place. So they cannot use their sign language in the same cafe. So she has to eventually post that. But fortunately for Maria, she has a translator. So she can talk in Spanish. That Spanish is converted by the translator to English. And then there's the post office. And then via the post office, she gets that letter. And again, she has a translator, and then Anne understands whatever Maria has transmitted, and vice versa from Anne to Maria, right? So now only one layer is not possible. There are three layers in that case: layer 3, layer 2, layer 1. So you can see the importance of layers in this case, because Maria cannot communicate to Anne directly. She has to use layering, and in each layer the functionality is different, although the purpose is same, to communicate with Anne. This is the purpose, but she has to use a different layer. So we have a layer 3 and we have a layer 2 and we have a layer 1. So from this you can understand that layering is important. In the same way, whenever machines communicate with each other, they should have some kind of layering mechanism. In each layer, there is some different functionality. But as I said before, the objective is same, to communicate with the other machine, right? So this is the importance of layering. Now I will tell you about the OSI model. That was established in 1947. The International Standards Organization is a multinational body dedicated to worldwide agreement on international standards. So you must have seen on different kinds of devices, they have written ISO certified, right? So ISO in the International Standard Organization, and it is dedicated to the worldwide agreement. Obviously, most of the countries are part of that. Almost 3/4 of the countries in the world are represented in the ISO, right? So an ISO standard that covers all aspects of network communication. So network part of that is the open system interconnection model. So it was established in late 1970s. So there's ISO, and then we have an OSI model that is given by the ISO. So ISO is the organization, International Standard Organization, and OSI is the model. So do not confuse both of them, right? Right. So in the OSI model, we have 7 different layers. The first one, or actually the layer 7 is the application layer, which is closest to the user, which is closest to the one who is using the application, right? And then we have a presentation layer, then we have a session, transport, network, data link, and the last one is the physical layer that is also called as a layer 1. So in the OSI layers, when the device A wants to communicate with the device B, we have intermediate nodes as well. So device A has something closest to that device is the application layer. The application layer goes to the presentation layer, it goes to the session layer, it goes to the transport layer, it goes to the network, data link, physical layer, and from the physical layer, it goes to the nodes. You can see in the nodes, it is not going all, it does not have to pass through the session layer or the presentation layer or the application layer, because the purpose of intermediate node is just to pass on whatever it has received to the next node. So it has no purpose to go to the application or see what the application is. It will eventually go to the network layer at most and then transmit to the next node. Eventually, it will also go at max to the network layer. And then eventually it reaches out to device B, which goes from physical layer all towards application layer. And from the application layer, it is able to see what device A has transmitted, right? So this is, yes. So you can see that we have computer A, right? So it has application layer, and then it has to move on towards the physical layer, and then we have transmission medium, and then transmission medium goes all, it has to pass through all those layers and eventually to the application layer of this. So you can see the size of the application layer is small. Why the size of the application layer is small? Because it only has a header and the data. But when that layer passes on to the next layer, it adds those details that is concerned with that layer, the additional details. So the size of the packet gets bigger, bigger, and eventually the size of the packet is biggest when it reaches to the physical layer. And then that eventually that packet or that chunk is transmitted to the transmission medium, whatever kind of medium that is. And then it has to pass through all the layers and eventually to the other computer. The physical layer is responsible for moving individual bits from one node to the next. So eventually the things that are moving, or the thing that is being transmitted from node to node, that is basically, it is being passed on by the physical layer. And actually it is the physical layer that receives that data from the other node. So remember that the physical layer is responsible for moving individual bits from one node to the next. So in this slide, you can see a summary of each of the layer, right? Obviously, each layer has a lot of different things that it has to do. But this is sort of a naive information related to each node. So what is the application layer? It allows access to network resources. This is a one-liner of each. Obviously, you will go through the detail in a little while. The presentation layer translates, encrypts, and compresses the data. The session layer establishes, manages, and terminates the sessions. The transport layer provides a reliable process-to-process message delivery and error recovery. Network layer moves packets from source to the destination and provide internetworking. Data link layer provides organized bits into frames and provides hop-to-hop delivery, and physical layer transmits bits over the medium to provide mechanical and electrical specifications. This is sort of a summary of each layer. The TCP/IP protocol suite was developed prior to the OSI model. Therefore, the layers in the TCP/IP protocol suite do not match exactly with those in the OSI model. The original TCP/IP protocol suite was defined as 4 software layers built upon the hardware. So today, however, TCP/IP is thought of as a 5-layer model with the layers named similar to the ones in the OSI model that you can see shortly. So what is this? This? You have application layer, you have transport layer, you have internet layer, you have network layer, and then you have some hardware device. So these were the original layers, and the layers that were later updated so that it can get integrated with the OSI model. The names were changed a bit. So there was application layer, transport layer. Instead of internet layer, we called it a network layer, because network was the name that was also being used in the OSI model. And then we have data link layer instead of a network interface. And then instead of saying the hardware devices, we call it the physical layer. We call it the physical layer, right? So there's a difference between TCP/IP protocol and the OSI model. So you can see that physical layer is related to the physical layer. The data link layer is related to the data link. Network is related to the network. Transport is related to transport. But instead of having session, presentation, and application layer, all of the functionalities of these 3 layers is encapsulated in this application layer or merged in this application layer, right? So there are several application layer protocols. There are several transport protocols, internet protocol, and some helping protocols, and underlying LAN and WAN technology comes into these 2, data link and the physical layer. So this is a sort of a private internet, you say. You can say this is a private internet. We have a link 1, and then we have a link 6. So it has a computer A, it has a computer B. You can see that there are intermediate routers and links between these. So eventually the data is received at computer B. So let us see. So this is a physical layer. So the physical layer, from the physical layer, it is going on to this node R1. You can see that this black dot is sort of telling you that the data is being received, and that empty hole is telling you that the data is being transmitted from the same server. Yes. So this source of a source and destination. So the filled hole is destination and the open hole is the source. So you can see that it is going from node to node, and we are eventually describing this in the form of the physical layer only. So this is only physical layer description of this. You can see that from the physical layer of A, it is going to the physical layer of router R1. From physical layer of the R1, it is going to the physical layer of R3, and eventually to point B. So the unit of communication at the physical layer is a bit. So what is the unit at the physical layer? That is a bit, right? So when we talk about the data link layer, now I'm talking about the data link layer. So what happens? From the computer A, right? Computer A, for example, is at the data link level, right? So from the data link of computer A, it is going to the physical layer of computer A. From the physical layer of the computer A, it is going to the physical layer of router R1. And then to the data link layer of R1. And from the data link layer of R1, it is going to the physical layer of R1. And then from this to the physical layer of R3. So you can see that this is how the data is being transported, or data is being moved on from node to node. So you can see that instead of bits, the unit in this case is a frame. We call it a frame. So whenever you're talking about something in the data link layer, you don't say I'm using bits, you say I'm using frames, right? So next is the network layer. So if there is a communication from the network layer, if you're at the network layer of computer A, you will move the data from network to the data link layer of the computer A. from the data link to the physical layer, and from the physical to the physical layer of R1, and from physical to the data link, and from data link to the network, and then in the reverse direction, right? Yes. So the unit in this case is datagram. So whenever you're talking about the unit or the information that is being carried at the network layer, that is basically the datagram. Datagram is a unit. Next is the transport layer. Again, you can see the same kind of phenomena is being done: transport, network, data link, physical, and vice versa. But what is the difference here? You can see that in case of router R1, it is going to the physical layer of router R1, to the data link layer of R1, and then to the network layer of R1. It is not going to the transport layer of R1, because the purpose of R1 is not what the transport layer purpose is for computer A, right? So purpose of R1 or the intermediate switches is being dealt with up till the network layer. It does not go all, it passes through the, the application layer that is only for the devices. This is only for the, not the switching nodes, but rather the computers or the servers or whatever, right? But the purpose of switching node is, restricted till the network layer, and it does not pass the data to the transport layer. So this is the thing that was important. And you can see that the unit here is what? The unit is segment. The unit communication unit at the transport layer is a segment. So user datagram or a packet, depending on the specific protocol that is being used in that layer. For example, if you're using switch, then obviously you will not pass on the data to the transport layer. So the unit in that case would be obviously datagram, right? But as far as computer A and computer B is concerned, the unit at the transport layer is a segment. Unit at transport layer is a segment. Now we're going to talk about the application layer. In case of application layer, it will pass on to the transport, network, data link, and eventually, as far as routers and intermediate switches are concerned, you know that the data is restricted till the network layer. It will not pass the data to the transport layer. It does not have any transport layer, the intermediate switches. And that is how the data is being routed from node to node. You can see that unit here of the communication is a message. The unit of communication at the application layer is a message, right?